Hello, trig class. This is 7.6 graphs of sinusoidal functions. This whole section is long, so there's going to be probably 3 to 4 videos covering it. So I wanted to let you know that up front. And also, before we start these, make sure you have your unit circle handy, because I'm going to be plugging in values, and if you're wondering where I'm getting them from, it is from the unit circle. Okay, so the graph that we're going to be doing first is y equals sine x. So there's a chart below that we're going to fill out. There's not enough space for the y. So what I'm going to do here is I'm just going to extend some lines so you can do the same to make your chart. And we're just going to plug in the values after we work them out. And then we'll fill out the chart and figure out what the coordinate point is, because we need these coordinate points to graph sine of x on the plane. Okay, so let's go ahead and do the first one. The first one asks us to find sine of x when x equals 0. So all we're going to do is plug in 0. If you look on your unit circle, you'll see sine at 0 is 0. Okay, so the y value is 0. That gives me the coordinate point 0, 0. Second one, sine of pi over 6. Now pi over 6, remember, is 30 degrees. So sine of 30 degrees is 1/2. Okay, so my next coordinate point is going to be pi over 6, comma, 1/2. Sine at pi over 2. Pi over 2 is 90 degrees, and sine at 90 degrees is 1. So I get the point pi over 2, comma, 1. 5 pi over 6. Sine at 5 pi over 6 equals 1/2. So I have 1/2. We have 5 pi over 6, comma, 1/2. Okay, next one is sine at pi. Okay, so if you look up sine at pi, you're going to see that it's 0. So the coordinate point is pi 0. Next, sine at 7 pi over 6. Remember, that's quadrant 3. So sine in quadrant 3 is going to give us a negative 1/2. Okay, so I get 7 pi over 6, comma, negative 1/2. Okay, 3 pi over 2 is next. So sine at 3 pi over 2, that is 270 degrees, is negative 1. So I get 3 pi over 2, comma, negative 1. Alright. Sine at 11 pi over 6 gives me negative 1/2. So I plug in negative 1/2 here, and we get 11 pi over 6, comma, negative 1/2. And finally, back to the beginning, we get sine of 2 pi, which is 360 degrees, and we're back to 0 again. So this is 2 pi, comma, 0. Notice my x, when I'm plugging in stuff, is an angle, and then what I'm getting out is the value at that angle. Okay, so what we're going to do is we're going to take all of the points we just found that I just highlighted here, our coordinate points, and we're going to graph them to see what the graph of sine looks like. Okay, so first off, I do want to mention that the author was picking values of pi over 6 in the different quadrants, and the reason for that is that we want to use values where sine equals a number that we can figure out. For instance, if we picked sine of 60 degrees, we'd get 3 pi over 2, and that's going to be hard to graph. So 1/2 is much better. So this is going to be the graph of y equals sine x, and it's going to show 1 period, and that's going to make sense later. Okay, so what I'm going to do is I'm going to put in the 4 key points. The 4 key points for sine are pi over 2, that's 90 degrees, pi, that is 180 degrees, 3 pi over 2, that's 270, and then 2 pi. Okay, the values that we received were 1/2, and the other possibility is 1. And then we went down to negative 1/2 and negative 1. Okay, So this is y and this is x. So your x-axis are your angles, and your y-axis are your values at those angles. Okay, so the first one we had was pi over 6. So that's about a third of the way to pi over 2. So I put that one in there. So let's go back and do sine of 0. So sine of 0 is 0, so let's go ahead and put a dot here. And then sine at pi over 6 is 1/2. Sine at pi over 2 is 1. Okay, now we're asked to find sine of 5 pi over 6. Now that's going to be like 30 degrees away from, sorry about that, guys. I'm going to pause for a second. Okay. So 5 pi over 6 is going to be 30 degrees away from pi over 2, and it's also 1/2. Okay, let's move on. Sine at pi is 0, and then 30 degrees from that is 7 pi over 6. And sine at 7 pi over 6 is negative 1/2. Okay, sine at 3 pi over 2 is negative 1. Okay, and then 30 degrees away from 2 pi is actually 11 pi over 6. And the value at sine at 11 pi over 6 was negative 1/2, and then back up to 2 pi. Alright, so if we connect the dots and my graph's a little wonky, we should get a curve that looks like this. So let me just, kind of fix this a little bit. This is called the sine graph. Okay, so that's very important to know. You have to memorize what it looks like. We'll be using it over and over and over again. Alright, next page. Okay, so the graph we just saw was 1 period. 1 period of sine, again, is 2 pi. Okay, so now we can actually see what it looks like. So if you go back to that previous page that you just drew in, there are certain properties of sine x that we have to know. For starters, the domain, that means all possible x values, is negative infinity to positive infinity. Okay, the range, that's how high the graph is. It goes from negative 1, including negative 1, and positive 1, including positive 1. Sine, and we're going to learn about even odd functions in a little bit. Sine is odd, which means it has symmetry with respect to the origin. Sine is also periodic with a period of 2 pi, and we just saw that. Remember that that means that the graph of pi repeats every 2 pi units. The x-intercepts, that means where does it touch the x-axis? And if we look at those, they occur at 0, pi, and 2 pi. So we can say that they are, they repeat every k pi. We can let k be a constant, so that way we know that at every multiple of pi, that's where the x-intercepts are. Okay, the y-intercept is 0, 0, and the maximum value is 1. The maximum means the tallest value, and where does it occur? It occurs at pi over 2. Okay, the rest of it. The minimum value, it occurs at negative 1, the lowest point on the graph, and it occurs at 3 pi over 2. Alright, the next objective asks you to graph the function with transformations. So the a that you see here is called amplitude. That's going to be the height of the graph. That gives us vertical stretch or compression. It should be an M. Here, let's. I'm just going to erase that just so you can read it. So once again, vertical stretch makes it taller, or compression makes it smaller. Omega is the horizontal compression or stretching. Okay, this little omega, that'll determine how fast your wave is going. So for instance, if I have sine 2x, that means that omega is making the graph go twice as fast. Okay, so that's what omega does just in general. Okay, They asked us to graph y equals 3 sine x, and what I'm going to do is we're going to go to the next page so I have some graph paper so I can show you what to do. First of all, we have to know this graph that I'm going to draw, and you have to know it by heart, so you need to practice it. Okay, here's 1, here's -1. The graph that I'm going to do is y equals sine x. Okay, the 4 key values are pi over 2, pi, 3 pi over 2, and 2 pi. Okay? The graph starts at 0, goes to 1, comes back down to 0, goes to -1, and then comes back to 0. Okay, so what does that look like? It looks like this. Okay, you have to have this graph memorized. And once again, the 4 key values is very important. If I have done nothing, and I've just have y equals sine x, I have the 4 key values as pi over 2, pi, 3 pi over 2, and 2 pi. Those are the key values around the unit circle, the 90-degree marks, if you will. Okay? Alright, so you have to have that memorized. If you have that memorized, then doing the transformations is no big deal. So what I like to do is I like to use graph paper for a couple reasons. One, it allows me to line things up. So I'm going to use a different color here, and I'm going to pull the opacity down. And I'm going to make little dots here so we can line some stuff up. Okay, so what I'm doing now is I'm just writing out the 4 key values. I'm bringing them down so they're all lined up nicely. And we're going to see what happens to our graph when we have a 3 in front of x. Or sorry, that's not the graph. The graph is actually, and let me go back to get a different color. The graph they're asking you to draw is y equals 3 sine x. Okay, the 3 here, that 3 is the amplitude, so a equals 3. Now, remember I told you it's going to do either horizontal stretching or compressing. Okay, so the 3 actually makes it taller because now my whole function is multiplied by 3. Okay, so let me go ahead and mark some stuff over here. Here's 1, here's 2, here's 3. Here's -1, here's -2, and here's -3. Okay, key values are still pi over 2, that hasn't changed, pi, 3 pi over 2, and finally 2 pi. Okay, so in the original graph, at 0, I have 0. That's my output, so 3 times 0 is 0. Okay, at pi over 2, the value was 1. See? So if I multiply 1 by 3, I get 3. So now my graph is going clear up to 3 instead of 1. Okay, at pi, it's 0. So 0 times 3 is 0. At 3 pi over 2, it's -1. So -1 times 3 is -3. And then finally, 2 pi, 0 times 3 is 0. So let's go ahead and graph that out. So you can see that the graph is now 3 times taller than sine of x. I do want to point out that I used a different scale on the y-axis. The original one I did 2 units up to hit 1, and then this one down below I just did 1, 2, 3. Okay? But if you do this and you line everything up, it makes things much more lovely. Okay, I'm going to do one more and then I'm going to stop this recording and then we'll do part 2. The next question you have to do is graph y equals negative sine of 2x using transformations. So before we do that, let's write a couple things down. Omega equals 2. Do you guys see there's something in front of x? And also, we have a negative sign. So the negative sign actually flips the graph over the y or excuse me, the x-axis. I lied to you. So it's over the x-axis. Okay, so let's see what this all looks like. To do this problem, first things first, draw the regular graph of sine of x. Okay, just so we know what it looks like. Okay, so here's -1, here's 1. 4 key points are pi over 2, pi, 3 pi over 2, and 2 pi. And guys, I'm going to fix this just so they're evenly spaced. I should have taken this out 2 units, so this will give you time to draw this up anyways. Okay, so pi over 2, pi, 3 pi over 2, 2 pi. Okay, I'm much happier with this. Alright, so the graph of sine, let's get a different color so it's a little brighter, cheerier, is this. Okay, start at 0, go to 1, go back to 0, go to 1, go back to 0. Okay. Alright. Now, they ask you to do 2 things. We're going to take care of omega first. To do that, I have to figure out where the period ends. In the regular graph, y equals sine x, which I just drew, the period is 2 pi. Okay? Now, we're looking at y equals 2 sine x. Or, no. Okay, we're looking at sine of 2x. Sorry about that. And that means that omega is going twice as fast. So being that said, that means that on my graph, one period of sine is going to hit pi, and then they're going to have another period of sine. So what does that look like? And by the way, I'll teach you a much more precise way to do this in a couple minutes, but just for now, just so you know what it looks like, we're going to be doing this. Oh, it keeps on doing that. Okay, so here's 1, here's -1. So this looks like this. So I just shrunk down what I just drew and ended it at pi. Now if I want to draw out the whole entire thing, here's 3 pi over 2, and I want to go to 2 pi, I have 2 sine graphs back to back. So it looks like this. I'm doing this one in red. Okay, so that's what y equals sine of 2x looks like. Now, I have to take this graph and I gotta flip it over. The reason why is because now we have to graph y equals negative sine x. Okay. Alright, so we're doing negative sine of 2x. Let's check it out. So, I'm going to do this. Once again, let's line stuff up. Here's pi over 2. Here's pi. Here's 3 pi over 2. And then finally 2 pi. This is my x, my angles, and y gives me my results. Okay. Alright, so if you flip something over, basically you're changing your output from positive to negative. So 0 doesn't get affected, so 0 is going to stay. If you look up here, and I'm going to just tap it with a highlighter, that is a maximum of 1. So if I put a negative in front of it, it becomes -1. Okay. And then back to 0. 0... You know, I can't change signs because it's not, you know, a real number. Well, actually, it's a real number, but you can't make -0. It doesn't make sense. Okay, now with this next spot, it's a -1. So -1 times a negative gives me a positive. Okay, now back down, it was, right here, it was positive. So we're going to go down to negative, and all I'm doing is flipping my values over. Okay, so that's all I did, was I flipped the values over the x-axis. So what was positive became negative, and what was negative became positive. And that is my final answer. So when you do your homework, I want to see you step through each and every step. So for instance, for this one, we take care of sine x, the parent. This is called the parent graph. And then you take care of omega, if you have one. And then the very last step should always be flipping it over. Okay, this is done for now. This is part 1. Part 2 is coming soon.